Let's now study more examples about if statements, and we'll see different cases of reasoning as well. All right, the first one, very easy. Let's say this will be the simplest if statement you can write. You only got one branch, and then you don't have any else. That's definitely allowed. And we just want to say this will be equivalent to, sometimes people like to write, let's say you got the if part over here, identical to this over here, but implicitly you might still put an else over here. You simply just put a comment here to say do nothing. So this might be nice to be explicit about what your intention is. Okay, let me just show you very quickly over here. Let's try to trace two examples over here, two inputs. So we got two versions over here, one just with the if without an optional else, and the other one with if and else. However, the else part simply just does nothing over here. All right, let's try that. The first input will be, let's say input is simply equal to 10. So now if we try 10 over here for the first version over here, so 10 larger than or equal to 0 is going to be true, meaning that we are going to execute this part of the code, and then it's simply just going to calculate the area, right? So that'll be area for circle is whatever value it is, right? I'm not going to bother with the exact value. What about the second version? For the second version over here, I'm also going to evaluate the first branch over here. It's going to be checking this. So 10 larger than or equal to 0, the same will just be true, right? We're also going to say something like area for circle is whatever value it is. All right, that's okay. What about the case where we are going to the else branch, or without even else, minus 23. So we're still trying to check these condition over here. Minus 23 larger than or equal to 0 is going to be false, meaning that bypass this one over here, and then we'll simply go to the end of the program, because we for this if statement over here, there's simply no else. On the other hand, if you try the second version over here, so minus 23 larger than or equal to 0 is going to be also false, which means we're going to bypass over here, and then we go to the else part over here conceptually, right? Go to the else part over here, which is implicitly the negation of this one over here, right? We talked about it before, just want to mention very quickly for you. Radius larger than or equal to 0 over here, and then we simply do nothing, right? In both cases, either we simply go out of the if, will be no input or no output over here, or we simply go to the else and do nothing, and then simply no output over here. All right, so they are equivalents. So which one to do is really up to you, but I recommend sometimes if you only got a single if, it might be nice for documentation purpose to put else with some comment to say do nothing for the else branch. All right, okay, let's move on. Let's now talk about primitive statements versus compound statements. Basically, simple versus complicated. That's what I meant. Right? A statement is simply a block of Java code that modifies values of some variables. Right? So basically, what we talk about in elementary programming, so those are primitive statements, variable assignments. And in assignment, well, okay, we talk about it. You can think about variable assignments is simply primitive, like a simple. Now, if statement is a compound statement in the sense that you actually got each branch can contain assignments over there, right? You can see, for example, over here, you can see for this if over here, that is a compound statement, because you can see inside the if you got line number 1 is a variable assignments, and line number 2 is actually a print statements. Each one of them, this is a simple one, this is a simple one, a primitive one, but now a compound one will combine all of them together. All right, so that's the difference between primitive and compound. And notice that for your if statement over here, it can even be nested, meaning that the body of the if statement over here, think about this. You can think here, the area over here is simply an assignment statements. However, in practice, it's very common to see, rather than having a primitive statement here, you can have just another if statement. It's called nested if statement. So that's something we'll see right away. All right, so you really know the difference between simple or primitive versus complicated or compound, right? Right, let's consider this example over here. It's pretty complicated enough. I do have quite a few things to say to you about this example over here. Let's now switch, all right? The first aspect I would like to talk about is about the using a little bit of what we learned before about logical operator properties or laws. Right? Let me just explain the structure over here very quickly. So we got assignment statements, line number 1, line number 2. That's easy. So now from line number 3 to line number 12, over here we have a single if statements. Okay, let me just try to highlight that for you. So over here you can think about the whole thing over here is a single if statements over here. So this is a single if statements. How many branches do we have? We got one branch and second branch. Okay, for the first branch, this is the body of the first branch. This is the body for the second branch. You can see for the body for the first branch itself is just another if statement over here, right? So now you get an idea. So I don't need to go any further. All right. So now I'd like to talk about under what circumstances are we going to execute a particular branch. That's quite important for you to see. All right. I chose 3 of them. So the first one, when will we execute y is assigned to x times 2, right? You will only see the expression over here, x larger than 10. That's a branching condition. However, there is something implicit over here. Think about we'll only get to this part over here, which is the second statement. You can think about first statement here, second statement here. The second statements of this particular branch. So when we talk about under what circumstances are we going to execute this statement over here, is really the combination of this and also this. Meaning that this must be true and also this must be true. Okay, let me put it out. So now for this one here, so the green one will be, for this one to be executed, so it will be x larger than or equal to 0 and also x larger than 10. Right? If you try to visualize that very quickly, larger than or equal to 0 over here, and then strictly larger than 10 over here. And then by taking conjunction, you're really doing intersection. So it would be just equivalent to larger than 10. Okay, this one is easy. It turns out to be just the same, but we did a little bit of reasoning over here. So now under the circumstance where x is larger than 10, are we going to execute this particular statement here? That one's not difficult, but just a warm up. What about the blue one over here? The blue one over here, when will we, under what circumstance are we going to execute this particular y is reassigned to x modulo 2? All right, think about this. It's going to be for sure this branching condition must be satisfied, and also this branching condition must be actually not satisfied. Agree? Okay, and also this branching condition must be satisfied. So these are the 3 that we have to worry about. So now number 1, x larger than or equal to 0 must be satisfied. That means we'll go into this branch. And also the first branch over here will actually evaluate to false. Otherwise we wouldn't get to the else if, would we? Okay, so that means not the case and not the case x larger than 10, right? That will be the part that should be false. Not the case x larger than 10. And also it should be, this branching condition should be true. And also x less than 10. All right, so now let's try to visualize this very quickly. So now x larger than or equal to 0 is over here. Not the case x is larger than 10 over here is equivalent to x less than or equal to 10, right? That's something we learned before. Less than or equal to 10. And also x less than 10. X less than 10 is actually just going to be about this. All right? Just about this. Let me just put it here. So larger than or equal to 0, and also less than or equal to 10, and also less than 10. So these are the 3 conditions. But now if we want to take the intersection of these, it's going to be basically over here, and then excluding 10, right? because when you when you're intersecting strictly less than and also less than or equal to, you're basically excluding the equal to 10. All right, so this will just be equivalent to x is between 0 and strictly less than 10. So this will be actually the condition over here. Right, so this is just logic that I would like you to know. All right, so that's exactly corresponding to basically larger than or equal to 0 and strictly less than 10. So that's the range. And then for the previous one, let me just put it here, strictly larger than 10. All right, guys, let's now do one more over here just for completeness. So what about under what circumstance are we going to execute this line over here? Similar, we're going to satisfy this. We're going to evaluate this. This one should be evaluated to false, and this one here should also be evaluated to false as well. So that means x larger than or equal to 0. Not the case x larger than 0, which means x less than or equal to 10. Not the case x less than 10, so that means x larger than or equal to 10. So now they should be all conjoined together, right? They should all be satisfied. So now let's see what's going to happen. What's going to happen is x larger than or equal to 0 is over here, and then less than or equal to 10, and then larger than or equal to 10. Okay, hopefully you can see that. Larger than or equal to 0, less than or equal to 10, larger than or equal to 10. And now, if you take the intersection, because of conjunction over here, it's going to be exactly just the value of 10. So that means x is equal to 10. Of course, you can. So here, equal is not assignment. I meant mathematical equality. All right. So now, this will simply correspond to this guy over here. So now, I want you to see this. Basically, what we ended up with, I'm just trying to prove to you. By writing if, else if, and else over here, we are really trying to split the number line into 3 regions: green, blue, and pink. Right? Let me put into a single one. You can see we already got the green to be strictly larger than 10, and we got a pink over here that's actually exactly equal to 10. And also finally we got a blue one over here. It's from 0 until 10, excluding 10. So you can see that's exactly the 3, 1, okay, 1 over here, 2 here, and 3 non-overlapping or disjoint intervals that we have. All right, so that's the number one observation you want to have for you. So recap. Given this piece of code that you saw on the slides over here, that's a clean version over here, how can you argue that this part over here is really trying to handle the 3 disjoint ranges on the number line over here, this one, and also this one? That's basically what I'm trying to show you. All right, second observation I'd like to talk to you about this example over here. We want to trace very quickly about this code. I'll do one over here on the paper. I'll do another one on the Eclipse because it's really important for you to use a debugger, and also the next one I'll leave that to you as an exercise. Let's try this one over here. If it is equal to 5, right? What is going to happen is, let's try this. So we're going to, let's say x is simply just going to be 5 from the user, and y is going to be 0. Okay, and then when we check this condition here, 5 larger than or equal to 0 is going to be true. So we're going to go in here, and then x is positive. We're going to print that to the console. Okay, and then we check this nested if statement over here, and then let's try this. 5 larger than 10 is actually false. That means we bypass over here. And then we're going to go to the else if part. And now 5 strictly less than 10 is going to be true. Meaning that we're going to do this particular reassignment. You can check the value of that yourself. And then since it's a single if statement, so we're going to bypass the rest. And after this, since this particular branch has been executed already, so the else part is just going to be bypassed as well. So that's what's going to happen. So if you think about the execution path, it's like this. Execute this line, followed by this line, followed by checking this condition over here. That's true. Execute the first line, its body of implementation, and check the first branch, which is false. So we don't really execute the body of implementation for that branch. And then we check this one here, and this one is actually true. So we execute it, and that's it. And then we go all the way to the end. and the rest is bypassed. All right, so let me just show you very quickly for completeness. It's really important to really for you to really use debugger. Okay, let's try x is equal to 10. Let's see what's going to happen. And then exercise for you. Okay, again, exercise. You want to trace on both paper and debugger. Let's now try x is equal to 10. And you may just want to re-download the Java projects because I kind of updated the source code. Okay, so go to nestedifstatements.java. Okay, so now we want to maybe put a breakpoint. Let's say right around the time that we are trying to check the if branch, the branching condition over here, line number 10, for example. And then we're going to launch the debugger. Let's say right click on the Java class and say debug as Java application. Okay, and then so now enter some integer for x. So now we're going to try the value 10 over here. Enter. Okay, so now we're going to switch to debug perspective. So now we are pausing over here right before we check this particular branching condition, right? So let me just now remove from the previous expressions over here. And then add a new expression. For example, I can say x larger than or equal to 0. I can predict because this branching condition is actually true. So now when I say step over, I'm not going to jump to the else part, right? I'm actually going to go into the body for this particular if statement. So if I say step over, I'll go to line number 11. All right, good. Line number step over, I just printed out x is positive to the console. And now let's predict again. X strictly larger than 10 over here is false. So which means I'm going to bypass the body over here. So I'm going to, if I say step over, I'm going to jump to line number 15. Step over, exactly, right? So now if I try again, x strictly less than 10, so that's actually false, which means I'm also going to bypass this part over here. So if I say step over, I'm going to jump to the body for the else, which will be line number 19. Step over, jump to over here, and then it's going to execute it to whatever result. You can also observe the value for x and y to see how they change, right? I'm going to let you do that. All right, so after this, we're now at the end of the body for this particular if statement over here. So now what's going to happen if I say step over? Are we going to execute the else part? The answer is no, because the if branch, this first satisfying branch, has been executed already. So now we're just going to say step over, it will jump to line number 29 outside the if statement, right? The current if statement is done. If I say step over, we'll go to line number 29, all right? So, and then say step over, and we are done. All right, so stop the debugger and then go back to Java perspective, always remember. All right, so that's about this particular nested if statement example. So hopefully that's thorough enough for you to trace on both the paper and also to trace on the Eclipse. Also to understand how to reason about the ranges that are actually explicit and also implicit, right? Really try to understand that. You might be tested maybe later for your understanding on that, right? Just be careful, get ready. All right, so now let me go on to the next example. Okay, so this is just an optional exercise over here. So remember we showed you flowchart when we spoke about if statement. If you want to draw a flowchart for this particular nested if statement, feel free, but it's not optional. It's not required. It's just optional. All right, let's take a look at this example here. So now this is so-called multi-way if statement, meaning that, so this if statement, this is single if statement, but you can either go for way number 1, way number 2, way number 3, way number 4. You got more than one way, so that's why it's called multi-way, right? If you got only two if and else, that means that would be two ways. All right, let me talk about this example here very quickly. So there is another way to write this multi-way as a single if statement here as a nested if statement. But how do we do that? I already gave you some visual hints. We got if, we got else if, we got else if, we got else, right? The way to rewrite is to think about if and else goes together. And then after if, that's after this else, is just another new if statement, if and else. And then the if over here, just another if and else. So that's why you can see I kind of group them together using color if else, and also nested if else, and also nested if and else. That's kind of the structure. Let's see how we can rewrite it quickly. But I'll just do this one quickly together with you. So now I would say if over here the score larger than or equal to 80.0, over here we're gonna say print out A. You know, for simplicity I'll just say A over here, but you know what I mean. And then else. And then else is going to be some big statement over here, and we're gonna do another if and else, right? So now this if will be nested, and then we'll say score larger than or equal to 70.0, and then that one there is going to be print out B. I'll say B over here. And then you can see the else part over here, and the else is just going to be like that, and the pink is just going to be if else, right? Okay, if the score larger than or equal to 60.0, in that case I'm gonna print out C over here. Okay, I'm just writing out of space. Okay, let me just put a little bit lower, but you can still see it. And then we also got else, and then it's gonna be F. Else, it will be F. Right, you can see the cleaner version in your slides, but I just want to show you this so you can see exactly how I derive from the left to the right. Okay, either writing this or writing this is okay. It's up to you. Let me just show you one tracing to make sure these two are really equivalent, because you will see for every input value you will go to see exactly the same execution path for the result. Let's say I want to do, let's say 71. Okay. And then for 83 and 59, you can do as an example on both the paper and also Eclipse. Let me just do on the paper, 71. All right, so now for 71, on the first version on the left, 71 larger than or equal to 80 is going to be false. So bypass. And then else if 71 larger than or equal to 70 is going to be true. So that means we're going to execute this. So that's going to be B. All right. So now execution path will be, we're going to check this over here, and then it's false, bypass, and then we're going to check this one over here, and then it's true, so that's why we're going to execute this, right? That's the execution path. What about the right hand side? Very similar. When we evaluate this, so now we have 71 larger than or equal to 80 is simply false, so bypass. And then we're going to go to the else part, right? And when we go to the else part, the first one to check would be this. And then it's going to be 71 larger than or equal to 70 is going to be true. So we're going to execute this. So now if you see the execution path, very similar. So you're going to still check this, and then false, bypass the body, go to the else, and then you're going to check the if condition, and then it's true. So we execute the body for that particular branch. All right. So guys, if you try the other two input, 83 and also 59, you will see exactly the same behavior between either version 1 with a single multi-way if statements, or version number 2 with a nested if statement. You want to try both to really go over to see how things work. I believe in your week number 3 Java tutorial video, I also show you something similar, maybe on the Eclipse. You can check that as well. All right, I'm gonna leave that to you. All right, so I think I already explained enough for you to understand this example here. Let me go back to the slides. All right, so this is just another one over here. Okay, let me say the next example, what it is about. You can see the current example here. You can see we simply got the else part over here, right? But what if we did this no else part? What would be what would be the behavior, and also what would be the corresponding nested if, right? Let's now do this example quickly. So this one here, I already put down everything here for you. You can see now the difference is we don't have the else, right? You can see the else part is gone. However, we still put the else, right? We said that if there's no else for the if, it will be as if you put the else, but just simply say do nothing, okay? And then the nested if else, if else, if else, and also if else, that's something I talked about previously, right? Let me just do one tracing together with you quickly. You can do the rest. 59. So now the pink one over here. So initially we simply set the letter grade string over here. So this should be letter grade actually. The variable letter grade initially is simply just F to begin with. And then we're going to evaluate this condition over here. So it's going to be 59 larger than or equal to 80, right? 59 is going to be false. So bypass. Evaluate this. 59 larger than or equal to 70, also false. Bypass. 59 larger than or equal to 60 is going to be false. So, it's also going to be bypassed, right? So now you can see none of the bodies are going to be run. So that means we'll simply just go to over here. So the result will be whatever the value that's initialized to, let it grade. So it will just be F. All right. So hopefully you can see that. Now let's try to trace the same value over here by using also 59, but on version number 2 over here. So for version number 2, we also begin with the letter grade to be F, right? Over here. F, still to be F to begin with. So we're going to check this. 59 larger than or equal to 80, false. Bypass. Go to the else branch and then go into the else branch. The first one to check will be 59 larger than or equal to 70 is going to be false. So bypass. Go to the else branch and go to the first line. 59 larger than or equal to 60 is also false. So bypass and go to the else branch. And the else branch simply do nothing, right? It's not going to do anything to the letter grade. And then you would go basically go to the end, go to the end, go to the end. So it will still be the same. So now if you compare the execution path for 59 for the first the version number 1, you initialize it to be F. Check this, bypass. Check this, bypass, and also check this, bypass, and then go to over here. For the second version on the right, initialize that to be F. Check this, bypass. Check this, bypass. Check this, bypass, and also you can think about conceptually you're really executing nothing, but just wouldn't have any effects to the letter grade, and then you go to the end. So these two are really equivalents, even without the else part over here. I just put some else doing nothing just to show you, right? All right, so these two examples are basically the same. I'm just trying to show you whether you have else over here or not. In that case, the corresponding nested if statement should be quite predictable to write. All right. Let's now go back to the slides and then move on to the next example. Okay, you can actually read over this particular slide over here. So there is something that we're going to talk about in slide number 56 later, but you can actually go there if you wish. But anyway, once I go to 56, we'll review this example again.